let's talk about empirical data, because I've shown, you know, that's what we have lots of, okay? I happen to be, I self-confess, I'm a fly fisherman. I took it up about 30 years ago and have really enjoyed going to many different beautiful places in the world, catching and releasing beautiful fish like this large male steelhead you can see here in spawning colors. This one's from the Babine River in northern British Columbia. This particular lodge keeps track of every fish that's caught and released by every angler and has done so since the 1980s. And every night at dinner, we write down every angler, every fish, whether it was male or female, how big is it, so on and so forth. We wrote down, just for interest, how big were these various fish, and we did it based on 5 years of data from 2010 through 2014. That's 3,474 steelhead that were caught and released at this particular lodge. And you can see all these yellow and gray areas here is the plot of the actual data of the weight of these steelhead. Now, I want to say something before going on about looking at the plot of the density functions about the life cycle of steelhead. These are not like salmon. This big, beautiful fish will go up the river, spawn up here near Babine Lake, and he'll probably swim down again, all the way down to the ocean, live in the ocean for another few years, come back, and maybe even be bigger yet, unless something happens to him. But these fish will do multiple spawning cycles, and that means that every fish that's in the river here is either, it's their first time, you know, they're born in the river, but it's either their first time coming back from salt water, or it's their second time coming back from salt water, in which case they tend to be bigger. They come back a few years later after having grown by eating plentiful food in the ocean. And this guy's probably a third or a fourth time spawner here, about 20 pounds this guy is, but most of these fish are in the range of 4 to 15 pounds or so. But all of them are either 1 salt, 2 salt, 3 salt, or 4 salt fish. There aren't any 1.5 salt fish. You know, they're discrete in that sense. So let's take a look at fish biologists don't know the questions. If you were to ask, what is the relative proportion of the fish in the river of 1 salt versus 2 salt fish biologists would have no idea. What's the relative population sizes? How many 1 salt fish are there in the river versus 2 salt fish? They would have no idea in that either. I've never seen any data along those lines because you can't distinguish. The fish all looks the same. Well, what if we took this data? There's the histogram of the data. Most people would represent it with a log normal distribution or something like that. That's the log normal. There's the 2-term metalog. But what if you go to 4, 6, 8, 10-term metalog? Wow. I mean, all of a sudden the metalog is showing you something in the data that you can't see just by looking at the data. It is showing you that there's an inherent bimodal shape in the 10-term metalog, and it naturally leads the question, well, gosh, maybe these 5-pounders are 1 salt fish, and maybe these 10-pounders are mostly 2 salt fish, right? I mean, there's a reason for this bimodality here. And that's an insight that a fish biologist could use and say, oh my goodness, here's a piece of information I didn't have. Maybe I should go back and look at my statistics, look at the other evidence I have and see whether this theory is right. So there's an example of giving somebody insight into data that they might not have otherwise.